Hello, my name is Parker and I will be talking about the Salmonella outbreak related to the PCA and what happened and what will we do to fix it. So an overview of the problem, there's a massive Salmonella outbreak linked to the Peanut Corporation of America plant in Blakely, Georgia. About 9 people died and 714 people fell ill. It turns out that the PCA had a history of FDA violations, including a violation in 1990 and 1991 due to high levels of aflatoxin. The recall in late 2008 and 2009 turned out to be the most expensive food recall in history, and it cost the peanut industry about $1 billion. In the aftermath, many manufacturing and inspection issues were found. The legal problems that ensued after the recall. Founder Hugh Parnell and his brother were convicted in 2014 of 71 criminal counts. Parnell was sentenced to 28 years and his brother to 20 years. The quality assurance manager was sentenced to 5 years and the plant managers were sentenced to 3 and 6 years in prison. Now, there are a few assumptions that we will make regarding the PCA's quality control methods. More than likely, there wasn't many of them. Quality specifications were most likely outside of legal constraints, and more than likely didn't follow specification limits at all, and the defects were probably found to exceed the specification limits. And more than likely, very few tests were completed. The Jamaica cycle was probably not properly incorporated or incorporated at all, and because of that, control charts were not done or completely ignored. Now, our statistical assumptions and calculations that we will do to help fix the problem. Our alpha value will be considered our producer's risk, which represents the probability of rejecting a good batch, so we want to keep our value low. For this, we will choose an alpha value of 0.05 to optimize the consumer and producer's risk. For our beta value, we will consider this the consumer's risk, and it will represent the probability of accepting a poor quality batch. And we would like to seek a beta of 0.05 to minimize the consumer's risk. Some more assumptions that we're going to make is that we'll want to know the variance from our sample data. We want to be able to know the variance to see where we are in our process. We'd also want a high power so to make sure that we correctly reject our null hypothesis. Also, we will use the central limit theorem, and through that we find that we want to test about 50 samples per batch. If any salmonella is found in our batches, we want to recognize the problem and implement the dynamic process in order to pinpoint the problem and fix it. Also, we're going to assume our standard deviation to be 0.1 units for maximum quality. So, our beta turns out, after calculating our probabilities, to be 0.057, which is about where we want it after wanting our beta to be 0.05. And by finding our beta, we can find our power, which is 0.943. A very good value which keeps the power of the test high, our consumer risk low, and making our process very good for maintaining good quality. Now, our quality costs in the short term are going to be very, very high due to there being a large amount of inspections and more than likely early batches being lost because we will be flushing out old issues that create problems. Over time, though, inspections would decrease as quality would increase, and long-term costs would be lower because lower quality units will be a lot less frequent. Costs from recalls and lawsuits will be almost completely eliminated as we grow in quality. Inspection tools that we'll need for our inspections will include hands-free washing and drying to limit the amount of germs that are created in the washing and drying process. We'll have freeze-thaw and incubators for storing our samples, a microscope with a breath shield to eliminate the amount of error that we get from inspectors' breath onto onto a sample. Also, disposable gloves, which will eliminate the error of germs coming off in inspectors' hands. So in conclusion, the BCA's demise could have easily been avoided by implementing simple quality control and inspection techniques, and by simply conforming to standards to maintain simple quality. Thank you.